All right, this is lesson 11, module 2. We're going to be multiplying decimals, and we want to estimate, okay? So when we're estimating, what do we want to write this out as? Well, we probably want to take this part right here, the 38, and let's turn it into another number. So let's make it 1.40, shall we? And what do we want to estimate for the 32? I think we should go with 30. How's that sound? Good? All right, so we take our 30, we write it right below. This way, the vertical method of multiplication is a lot easier. So the way we do this is very simple. I'll take the short way if you'd like me to. Since we've been working on this for the last month, I'm going to do the short way, okay? So I'm going to do 3 times 4. 3 times 4 is 12, right? And we can carry the 1. Then I'm going to do 3 times 1 is 3, plus this 1 is what? It's 4, right? Now watch this, because here's the tricky part when you do the shortcut. These 2 zeros right here, we count those and we go 1, 2 zeros. Okay, does that make sense? So what we're going to do is we're going to take our, let me just get rid of this highlighting for a second, okay? And that way I think it'll make a little more sense to you. We counted our 2 zeros, 1, 2, and we put them right here, 1 and 2 zeros, right? Everybody see that okay? Then what we're going to do is we're going to count the places behind the decimal. And the reason why we count the places behind the decimal is because there's going to be trickier problems in your future that you don't want to get fooled by a problem. So we have how many places behind the decimal? We have 2. So we just move our decimal over, and that is 42.00. Okay? And that's as easy as can be. But the big thing you got to remember is what? Is count the places behind the decimal. Okay? Okay, I would make a note of that. Just like I'm doing right here. Because if you write it out, you're more likely to remember it. And it says, count the places behind the decimal. All right, so let's go on to a different problem, shall we? Now our next problem we want to do is we want to do a standard algorithm. So let's say we have 1.43 and we're going to multiply it by, we'll make it easy numbers, 23. Okay? How do we do this? Well, we put our 23 here so we can do it vertically, right? What do we start with? Let's start with the 3 times 3 and put our answer down below that. 3 times 3 is 9. Now what do we do next? 3 times 4, right? 3 times 4 is 12, and we're going to carry the 1. A friend of mine said you ought to put the 1 right here above it because it's easier and you won't get confused by putting all of the numbers up here. I thought it was a good idea, so I'm going to try it. Now I'm going to do 3 times 1. 3 times 1 is 3 plus this one right here, right? Is 4. Now what do I do when I go over to this 2? This 2 is actually a 20, isn't it? Remember? So I'm going to take that and I'm going to put my 0 here as a placeholder because that's going to represent that I'm going over to what place I'm going over to the 10 place, aren't I? So now I'm going to go with 2 times 3, okay? I'm going to put that answer right here. Does that make sense? Okay, so 2 times 3 is 6. And we're going to do our next problem, which is 2 times 4, and we're going to put that here, right? So 2 times 4 is 8. And then we're going to do 2 times 1, right? And that's 2. Now we're going to add it all together. I'm going to put the add sign on the other side just because I'm running out of room on my screen. So 0 plus 9 is 0. 2 plus 6 is 8. 8 plus 4 is 12. Carry the 1. And 2 plus 1 is 3. Now what's the thing we need to remember? Now let me scroll up to this, because what did I write here? What's this? I want you to say it out loud with me. Count the places behind the decimal. So I'm going to do that. How many places do I have behind the decimal? I have 2. These 2 right here, right? So now I'm just going to move that over. 1. Wow, that was a messed up line, wasn't it? 1, 2, and I have 32.89. And that's how you would normally multiply the standard algorithm. Okay, so what's the trick in multiplying with decimals? The biggest trick you need to remember is, I'm going to put it in pink, count the places behind the decimal. Say it with me if you do. Count the places behind the decimal. And then you move those over, just like I showed you right here, and you'll never get a problem wrong. Okay? Well, thank you for joining me for Module 2, Lesson 10 and 11. Keep watching this if you don't get it, okay? And it'll make sense after a while. I love math. Right. There's one other kind of problem that they give you in chapter or lesson 11, and that is they say, well, if 73 times 1,563, if that is done correctly, you should come up with 114,099. That is the answer. Now, if that's the answer, now watch, and this is going to be tricky. Well, it's really not very tricky. Some people might find it tricky. Let's say, and I'm going to change my color here. Let me go with a color that, let's go with blue. Let's say I have my decimal right here. Okay, so what numbers are behind the decimal? The 5, the 6, and the 3, right? Now remember what I told you last time. What do you need to do? Count the places behind the decimal, right? So if we're counting the places behind the decimal, how many places do we have behind the decimal? 5, 6, and 3, right? How many places is that? 1, 2, 3 places. So what do? We start over here at the far right side, and we're going to count over 1, 2, 3 places, and our answer becomes 114.99 thousandths. That means 99 of 1,000 pieces, which is pretty small, isn't it? So, let me just go back to, I'll just remove that because I don't really want to confuse you. So it's that easy on doing these problems. If you have a problem that's exactly the same, and if the answer is right, and they put a decimal in a spot, then it's just a matter of counting the place behind the decimal and putting that decimal in the right spot. Okay, let me get rid of this. What I'd like to do is I would like to change it slightly for you, okay? Let's say I change I'll rewrite this. Let's say I change it. Let's say I put on my decimal, and I'll do it in purple this time. Let's see if you can see it. What if the decimal is in between the 6 and the 3? Where does the decimal go then in my answer? Well, what do? See? Count the places behind the decimal. So that's what we're going to do. We have one place behind the decimal. We move the decimal over one place. And what do we have? We have 11,409.9 or 9/10. Okay? So on problems like this where they give you the answer and they just put a decimal in between them, it's really, really, really simple to just do the problem, because then it's just a matter of putting the decimal in the right spot. What did you say? You said you wanted me to do one more? Okay, you crazy kids. Let's say I have my decimal here in between the 5 and the 6. Let me take it one step farther. Let's say I've got one in between the 5 and the 6, and let's say I also have one on the 7, in between the 7 and the 3. Now what am I going to do? What did I tell you? Count the places behind the decimal. Okay, well, let's do it. And it's this easy. This is so simple. It's amazing. I got 1, 2, 3 places behind the decimal, so that means I'm moving my decimal over 1, 2, 3 places. Do you see how that works? Decimals are not anything to be afraid of. They're easy to use once you know your problem. So let's say they didn't give you the answer. Well, just do it like a regular problem and then put your decimals where they're supposed to go and then count your place behind the decimal. It's that easy. Okay? So, I hope this lesson was helpful for you. I love math.